Okay. Hello and good evening. Welcome to this calculus class. So in this class, we'll be looking at differentiation of functions using the chain rule. In our previous lesson, we look at how we could differentiate functions using the general formula. So today, we're going to proceed to make use of the chain rule when it comes to differentiating the function of function. So we're going to apply the chain rule. So where does it change role? Where does it come into play? For instance, let's look at a situation where you have a function y is equals to 2x plus 5 raised to power 10. When you have a function of y is equals to 2x plus 5 in bracket raised to power 10, if you are asked to differentiate this function with respect to x, how do you go about it? Normally, in our first lesson, we said that when you have a function, let's say you have y is equals to x raised to power 10, that you can actually apply the general formula, which is that if you have the y equals to ax raised to power n, that your the y the x, which is your differential coefficient, is actually equals to n times a x raised to power n minus 1. You can actually apply this formula here. Applying this formula here, what will you get? You're going to arrive at 10x raised to power 9 if you have to differentiate this. Apply this formula. But this formula is not going to work here. This formula won't work in this instance because this is not straightforward. Here we have 2x plus 5. This is a binomial in bracket raised to power 10. Before you can actually apply this formula here, you have to expand this thing. Maybe you have to expand 10 times. That is 2x plus 5 times 2x plus 5 times 2x plus 5, 10 times. And now it's going to be cumbersome. So just 2x plus 5 is equal to 2. You could have done that. Expand the function and arrive at an answer. But in this case, to expand 10 times is going to be difficult. So you can actually apply a shortcut. There's what we call, this is a function of a function. There's what we call the chain rule. The chain rule is what we're going to use in this particular example here, this particular question. So how does the chain rule work? The chain rule tells you that, for instance, let's assume that you have a function which is a function of another function. Actually, you can actually go ahead and differentiate by making use of the fact that your dy dx is going to be equals to dy du times du dx. So basically, what a chain rule is all about is that if you have y as a function of u, you have y as a function of u, and u in this case is a function of x. You have y as a function of u and u is a function of x. Then your dy dx is going to be equals to dy du times du dx. So how does this work here? Yeah, like I told you, this is a function of a function. So what are you going to do is that you are going to replace 2x plus 5 with an alphabet. So you can say, okay, let u equals to 2x plus 5. Now, if u is equals to 2x plus 5, that means where you have 2x plus 5, you can actually replace it with u. So we can say that y is equals to u raised to power 10. So we can replace 2x plus 5 with u. So y is equals to u raised to power 10. So now, this is u. U is a function of x, and y is a function of u. So you can go ahead and differentiate u with respect to x and y with respect to u. So now, from the formula which I gave you, which we can actually apply here, that this is a chain rule. This is called chain rule. That your dy dx is going to be equals to dy du times du dx. So what are you going to do? What you're going to do is now is that we're going to look for dy du from here, and we're going to also look for du dx from here. So let's go ahead and do that. Our dy du is going to be equals to, we're going to apply this formula now. So in this case now, your x is actually u. So to avoid confusion, if you're not used to it, you can when you have rewrite the formula here, this formula as y equals to a u n. So your dy du will be equals to, this is a u n times a u n minus 1. So from here, the y, the u is going to be equals to, here you have an invisible one, which is not written. So that will be 10 times 1, which is 10. Now the power of u is going to decrease by 1. So that will be 10 minus 1, which is actually 9. So you have that dy du is equals to 10 u raised to power 9. Our dy du is what? 10 u raised to power 9. Okay, so now, since we've gotten dy du, we need to get our du dx. So du dx is going to be equals to, still applying the general formula. Although what we have here is dy du dx, you can replace the y with u now. Okay, so our dy du is going to be equals to 2x is the same thing as 2x raised to power 1. So this is going to be 1 times 2, which is 2. Then you have x raised to power 1 minus 1, which is actually 0. So you have x raised to power 0 here. X is, the power of x is going to decrease by 1. So 1 minus 1 is actually 0. Then over here, when this is a constant, this is a number. When you differentiate a constant or a number, you end up with 0. It's going to end up, you're going to end up having 0. So at the end of the day, du dx is equals to x raised to power 0 from indices. Anything raised to power 0 is equals to 1. So we have that x raised to power 0 here is 1. So you have 2 times 1, which is actually equals to 2. So your du dx is equals to 2. So now, our dy du was what? 10 u raised to power 9. Okay. So now, we go back to solve for our dy dx. dy dx is what? The chain rule is that dy du times du dx gives you the y dx. Now, our dy du is what? 10 u raised to power 9 times du dx. Our du dx is what? 2. So 10 u raised to power 9 is going to give us 2 times 10 is 20 u raised to power 9. But we can't leave it like this because originally our question did not involve u. There was no u in the original question. We only introduced u so as to be able to solve the question. So what was u? U, we said let u equals to 2x plus 5. So since u is 2x plus 5, you're going to bring back u into this answer. So while you have u, you are going to put 2x plus 5. So you have that 20 in place of u, you put your bracket 2x plus 5, bracket close, raised to power 9. So this is your final answer. The y the x is equals to 20 into bracket 2x plus 5 raised to power 9. So this is your final solution. This is actually your final solution. This is, like I said, this method is called the function of function, the chain rule. Whenever you have a function of function, a function that is not direct, a function that involves another function, you have to use the chain rule. When you bring in the chain rule, you have to bring an alphabet to represent that thing that is making your function cumbersome, like the 2x plus 5. We brought in u and set u equals to 2x plus 5. Then go ahead, find the u, the x. For a beginner, sometimes going from the y, the x to the u, the x might be cumbersome. So that's why I told that if you want to do the y, the u, you can. When you have u, yeah, you replace x with e. And in this other instance, when you are looking for the u, the x, change your y to u. With time, with constant practice, you're going to actually get used to it. So in case if you have any question, you can connect with me through my WhatsApp number. You can chat me up on WhatsApp, or you can drop your question in the comment section. Or so you can also contact me via my Instagram account. So I'm going to drop the details of my WhatsApp number and my Instagram account in the comment section, description section. So I'll go over to the next question, but before we go over, I would like you to subscribe to this channel so that whenever we are having any class, you can always connect with us. Also, click on the bell icon so that you will always be notified whenever I upload any video, whenever I'm having any live class. You can also connect with me via WhatsApp on my Instagram channel. Thank you. So we'll move over to the next example. So let me write my WhatsApp number. My WhatsApp number is +2348038295185. This is my WhatsApp number. While my Instagram account is my Instagram account name is actually Edisam, EDDYSAM, numerical 4 for real. So we are going to move over to the next example now. Okay. So our next example is that if y is equals to 5x raised to power 4 plus 3x raised to power 2, everything in bracket raised to power 5. Find the derivative of y with respect to x, or find the differential coefficient of y with respect to x, or find the y dx. So we are going to, this is a function of a function. This is a function of a function. No need having to go about expanding this 5 times. That would be too cumbersome. So we're going to apply the function of function rule, the chain rule, which says that the y dx is equals to the y du times the u dx. So in this example now, your this binomial 5x raised to power 4 plus 3x raised to power 2 is going to become our u. So we will say let u equals to 5x raised to power 4 plus 3x raised to power 2. Okay, so if u is equals to this, then automatically we're going to replace 5x raised to power 4 plus 3x raised to power 2 with u. So we're going to have that y is equals to u raised to power 5. This is now replaced with u. So what next do we do? We're going to look for the y the u and u the x. So here you have u. So from here you're going to look for the u the x. While from here you're going to look for the y the u. So yeah, this is where we can now apply the general formula, which I actually explained in the first video I did, in the first class, in the first lesson we actually had. In case you missed that lesson, I'm going to post the link in the description section, in the comment section, so you can actually watch that video first to have a clearer understanding. So yeah, the u, the x is actually equals to 4 times 5. Then your power here is going to decrease by 1. So you have x raised to power 4 minus 1 plus, over here, this is going to be 2 times 3. Then your power will diminish by 1, decrease by 1. So you're going to have 2 minus 1. So over here you have 4 times 5 is 20. X raised to power 4 plus 2 times 3 is 6. X raised to power 1, which we don't need to write any longer. We don't need to write that x is 1 here. So this is our du. This is our du, the x. This is our du, the x. So now, next, we need to get our dy du. Y is equals to u raised to power 5. So our dy du, applying the general formula. So you have an invisible one here. So let me just put that invisible one. So this is going to be 5 times 1. U. The power of the u is going to decrease by 1. So this is going to be 5u raised to power 5 minus 1, which gives us 5 times 1 is 5. U, 5 minus 1 is 4. So you have 5u raised to power 4. Okay, this is 4. Okay, so this is your the y, the u. The y, the u is actually equals to 5u raised to power 4. Okay, so this is your the y, the u is equals to 5u raised to power 4. So next, what do we do? This is our chain rule. We're now going to implement the chain rule. We'll put the values for the y, the u times the value for the u, the x. So the y, the x is equals to the y, the u. The y, the u is what? 5u raised to power 4. What is the u, the x? 20 x 4 plus 3x squared. Okay, so next, okay, the x is 20x4 plus 6x, sorry, plus 6x. Okay, this is our du dx, 20x4 plus 6x. So at the end of the day, to get the y dx, we need to, we only brought in this u to make it easier for us to solve. This u is not going to reflect in our final answer. So what was u? U was 5x4 plus 3x2. So we're going to bring 5x4 plus 3x2 to replace u. So this is going to be 5 into 5x4 plus 3x2 raised to power okay, this is going to be raised to power 4 and 20x4 plus 6x. So this is the final answer right now. So this is actually the application of the chain rule. We've actually solved the second example by applying the chain rule. So it's actually easy to apply. It's just a question of being able to identify what is your u and making use of it. So I think we're going to solve one more example. Then I'll give you some exercises to try on your own. We're going to solve one more. Then while I will give you some exercises to try on your own. So So, for our last example, if y is equals to root 5x minus 3, find the y, the x, find the derivative of y with respect to x if y is equals to root of 5x minus 3. So in this instance, how do you go about it? So does this look like a function of a function? Yes, although it's not clearly spelled out. So what we're going to do is that we are going to transform this equation to actually look like a function of a function. So we're going to write this. So applying the law of indices. From the law of indices, anything under the square root can be raised to power half. So we can write this equation as y is equals to 5x minus 3 raised to power half. 5x minus 3 raised to power half. So this is actually looking like a function. So at this point now, we can now apply the chain rule that the y, the x is equals to the y, the u times the u, the x. So our u is going to be 5x minus 3. So we say let u equals to 5x minus 3. Let u equals to 5x minus 3. So if u is equal to 5x minus 3, so we're going to replace 5x minus 3 with u. So y is actually equals to u raised to the power half. So now we're going to find out the u dx. So we have the u dx is equals to, this is 5x. The power here is actually 1. When no power is written, just know that what you have there is 1. So we have 1 times 5. 1 times 5, which is actually 5. Then for the x, this is going to be 1 minus 1. It's going to diminish 2 by 1. This is, which is going to give us x raised to the power 0. So for this side, this is 3. This is actually 3. This is a constant. This is a pure number. When you differentiate, it's going to give you 0. So this is x raised to the power 0. 1 minus 1 is 0. So x raised to the power 0. So for indices, anything raised to the power 0 is actually 1. So what you have here at the end of the day is 5 times 1. X raised to the power 0 is 1. So what do you have? You have 5. The u, the x is equals to 5. So now, next we are going to look for the y du. Your dy du is going to be equals to, here you have an invisible 1. So that will be half times 1. Half times 1 is half. Then u, the power there, which is half, is going to decrease by 1. So that will be half minus 1, which at the end of the day gives you half into u. Half minus 1 is minus half. So you can write it in a more better way as applying the law of indices. U raised to the power half is the same thing as 1 over u raised to the power half. U raised to the power minus half. When this u comes down, the power will become positive. So we have 1 over 2 u raised to the power half. And at the end of the day, this can still be written as a u raised to the power half is the same thing as square root of u. So you can write it as square root of u. So this is our dy du. So at this point now, we can bring in our chain rule. We can apply our chain rule. We have our dy du as half 1 over 2 root u, or square root of u. And we have our du dx as 5. So we combine everything together to get our dy dx. So our dy dx is equals to dy du, which is a half root u, times our du dx, which is 5. So what do you have? This is going to give you 5 over 2 root u. Now, like I said, you can't leave your answer with u. What was u? U was equals to 5x minus 3. So you're going to replace u with 5x minus 3. So your dy dx is equals to 5 over 2 into square root of, what is u? 5x minus 3. This is your final answer. This is your final answer. So right now I'm going to give you some exercises to try on your own. I'm going to give you some exercises to try on your own. So the first one is y is equals to 2x, or let's change it to y is equals to 8x 4 plus 2x 3 raised to power 7. The second one is y is equals to 1 over 3 minus x raised to power 4. Then the third one is y is equals to 1 over x raised to power 2 plus 2x plus 1. So find the divided x in these three instances by applying the chain rule. If you have any difficulty, you can contact me via my social media accounts, either on WhatsApp, which is my WhatsApp number is +2348038295185, and you can also connect with me on Instagram via my Instagram account is actually Edisam EDDYSAM numerical 4 Rio. This is my Instagram username. You can these platforms, but please before you leave this channel, subscribe to the video, subscribe to the channel, like the video, and click on the bell icon so you'll always be notified whenever we have any lecture. And also very soon we'll commence our physics classes, online classes, YouTube classes. So if you have any challenge, just contact me and let me know. I hope you actually had a great time. If you sometimes you might need to go over the video more than once to actually assimilate. There's nothing actually difficult with differentiation. It's just giving it a little time, and you will actually imbibe the skills to solve the problems. Thank you. Bye. We're going to meet in the next class. Bye.